And, you know, unfortunately or unfortunately for us, right, the internet is forever. And anything you ever put there is going to be there forever. Please don't even talk about it. You can't get rid of it, right? You know, I guess there's a movie coming out with Cameron Diaz that talks about that kind of problem. I'm not so sure I want to see that. But everything is connected to the internet. The things that are doing the connecting are becoming much more sophisticated, right? The amount of compute that's in a phone is more than it was in an IBM mainframe in 1964, probably even in 1974, maybe even 1984. But now people are taking that data, collecting it, and making it available to themselves, and they're selling it to other people, right? You know that you can go to the phone company and you can buy, cell phone company, and you can buy location data for every phone that they manage, right? They'll package it up for the right price. They'll package it up and send it to you. They won't give it to you by phone number. They'll just say, our phone number 1 was here, 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 here. Our phone number 2 was here, 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 here. Our phone number 3,467,000 was here, here, here. Now, think about that, right? Maybe it's not all that interesting in and of itself, but I combine that data with Google Maps, and now I know where people were and what they were doing. And then I start to think about, where does your phone spend 8 hours a night if you sleep for 8 hours a night? Where does your phone spend 5 hours a night or 4 hours a night? Mine's by my, I empty out my pockets, so it's in my bedroom probably, right? So I take my phone and lay it down. It's pretty static for 4 or 5 hours, right? I take that, combine it with Google information, right? I take Google information and I go to the county website, which will take the geographic coordinates and turn it into a street address, right? And now the 3 telephones that spend their time at the geographical coordinates that are at my house are now cataloged, right? And so they can go, hey, who owns that house? Well, Scott Fagen owns that house. Cole Fagen owns that house. Right? There's 3 phones there. Maybe one of their kids has a phone, right? And now, where does the phone go to work, right? Where does it spend 8 hours a day, or 10 hours a day, or 12 hours a day, depending on how long you work, right? Now, it used to be that my wife and I went in opposite directions to work. Now we go to the same place, so trying to discern what's going on is a little harder, right? When she went to IBM and I came, and I stayed at home, it was easy to figure out whose phone was whose. And now, they also know, they go to my Facebook page, right? I have pictures from all different places that are tagged with locational information. Hey, Scott was there, and Nicole was there. I can figure out whose phone's whose. And next thing you know, I'm walking into a mall and I get 53 coupons, right? Come to my store. You're at the mall anyway, right? One time I left my phone on a plane and it flew over the wall. That was, not a problem, right? Just can't stop it, right? So, I just try to, get a little bit of a definition here. So big data is not only the fact that there's all this data that has not been cataloged and put together in meaningful ways, but it's now the ability to take this stuff and do something useful, right? In the old days, how did people choose to trade stocks? There was one crazy guy with really thick glasses and a green eye shade. He stared at all the right stuff and he goes, buy them, sell them, hold on to this. Think about increasing this, sell that short, right? After, now I can watch every stock in the market, right? It's not like I have to watch the little ticker at the bottom of the Bloomberg station or the Business Channel station. I can go off and I can have a program out there just consuming all this stuff at the same time and not only just do trade-offs in stocks, but look at mutual funds, look at commodities, right? Do I want to buy oil? Do I want to buy oil or IBM, right? That kind of decision making becomes possible, whereas in the past, right, doing that kind of comparative analysis wasn't. Or at least it was done by people who were really smart or savants about this stuff. And this has all become possible because compute has plummeted in cost, right? I've talked about this a few times here, right? In 1964, the machine was $1 million. It did very little, and the people all cost $10,000 a piece. Now the machine costs next to nothing, the software costs everything, and the people are really expensive. So you're trading off the right resources now, right? And people have kind of, and guys like Google and Yahoo, they feel that it's their place in life to some extent to give the technology away and damage and destroy people like IBM and Microsoft, and we become collateral damage in those areas, right? A lot of this stuff is basically what fell out of Google search, Facebook and Yahoo and the algorithms that they built, right? So, we've got these things of no SQL databases. No SQL doesn't mean it doesn't do SQL, it means not only SQL. I had to learn that one, right? But there's a lot of new technologies here. It's funny, oddly enough, some of them look a little like Datacom and a little bit like IDMS, right? It's just that, we organize the information a little bit differently, and some things become possible. There's a whole lot of work around, this idea of scanning information as it comes to you in real time, tagging it, cataloging it, comparing it to periods or that are similar, like the time series facility in Chorus, the idea of being able to do that and start to spot anomalies and be able to explain things based on anomalous behavior, like your system's going to come down, or the turbofan in the airplane's going to fail, right? You get that turbofan out of the plane before you're over the ground, right? Before the thing fails while you're in flight. And again, because the hardware costs almost nothing now, right? Rather than building a big machine with thousands and thousands of processors, I think Sequent, CDC Cybers, Texas Instruments had a bunch of these in the 80s, right? Just take a whole bunch of computers. The networks are pretty fast. You don't necessarily need the answer in split-second timing. Hook them all together and do these do these kind of massively parallel tasks against large pieces of data at the, on really relatively cheap computers. My first job in computing was actually writing vector Fortran to do weather analysis and prediction. Right? The machine had 65,535, well, more than that, but it had 65,535 processors to do the same math to a bunch of data, right? You fed it an array, and then you fed it another array, and you could say, add, boom, it all happened at once, right? IBM had a vector processor. It wasn't quite so profound, but it allowed you to do things. So this is really what behind the thinking on Hadoop and other massively parallel environments like that. So you kind of step back and you go, okay, so what are some real life examples, right? IBM likes to tout Watson. Right? Watson's a massively parallel set of Power 7 servers, right? The four in the picture here are actually, this stack goes back, there's like several dozen of them all working together. And what you do is you feed them all the same information, and they all process a different part of this massive data set. Sounds a little like Google or Yahoo search or anything like that. So I watched that on TV, and all my old buddies at IBM, one of the guys who I hired is actually working on Watson. They're like, this is the greatest thing since sliced bread. We are so far beyond everybody. And I said, for some reason, I just doubt that. It's really different. So I sat down. When I was watching, I actually DVR'd the Jeopardies, right? And I sat down with my laptop, and all I did was I typed the category, at the top, and the answer, and I just typed it into Google flat like that. You know what? The first hit on almost every question was exactly what Watson answered. Right? And it had the same problem with the airport question in Toronto. Right? It had the same issue because the question was kind of constructed oddly in English, so the thing was not able to parse it very easily. So, right? So you don't need, a several $1 million P7 cluster to do this stuff, right? Google and Yahoo and Microsoft are all doing it with commodity hardware. As a matter of fact, their whole business model is around building the cheapest server and having essentially people running around on roller skates throwing them away when they fail. They just don't care. So it's not technically hard. It's just now becoming economically feasible to do. All right, so a little bit more on just the overall technologies, right? The biggest one, who hasn't heard of Hadoop? Good. So you know all you need to know about big data. Right? This is the one. Right? Everybody's out there. And essentially, what it does is it allows you to take lots of data and do things like correlation against it. Right? Find stuff. go and find all the people who made a trip to Flint, Michigan, right? I mean, that's the kind of thing that it's set up for. It's actually very flexible. The more resource you throw at it, the faster it does. And it's really just a specialized environment with kind of four pieces, right? It's the software that, basically controls the cluster, does things, it's kind of a four-man sysplex or four-man's, local area network with some controls around it. A logical data store, right? Again, they were building this with commodity hardware, and the logical data store were the disks inside the commodity hardware. So it's just basically a virtual file system that allows you to look at all the disks at the same time. And then above it, right, you've got lots of job schedulers. This is a very simple job scheduler, which is, run this piece of compute against a piece, go find the next piece of data, run this piece of compute against it, and just keep it all in sequence. And then this kind of, I don't know if you want to call it technology, but this thing called MapReduce. And MapReduce is just a means of being able to find patterns, find things that are common. Right? So if you say that the important thing is Flint, Michigan, right? You can go and find all of the data that has a relationship to Flint, Michigan in your data set, right? So people who've flown there, people who've driven there, people who live there, people whose phones passed in, through, or over, right? All that kind of stuff can be done, and it will basically belch that stuff up really quickly. So, again, right, typically, right, Vince will tell me where I'm going wrong. Typically, that's pretty painful in relational databases to do. You have to kind of run through the entire data set to be able to get answers like that. This HDFS structure allows you, one, to separate the compute so many things can go after it at the same time, and two, it reorganizes the data internally to make those kinds of searches much less expensive and occur much quickly. Now, at the other side of it, I don't think I would want to do transactional activity against an HDFS, right? Because then you'd wind up blocking the entire data set to be able to make sense of it, right? So these, the technologies are different, and they're different for, for reasons of you want to do different things to them. Right. So we talked a lot about this. You do have to be, to some extent, a data scientist to be able to do this stuff. You have to understand the data. You kind of have to have an understanding of what the data is about before you can start. But you can cram lots of stuff together and do this correlation and get some insights out of it. The way this stuff is built, right, I think this came out of a Google project at some point, and some of the guys, came out of Google. They formed companies like Cloudera, Hortonworks, and NapR. They don't actually do anything to Hadoop. They provide a management structure around it, like GSUN a little bit, right? What we do around ZOS, what we do around infrastructure management. So they all have competing technologies for managing the cluster, getting data in and out of the cluster. Cloudera has got something that's pretty interesting called Impala, which makes the data in the database look relational. So you can try to apply applications to it in that way. But they're all kind of duking it out, and I put them in the order of what seems to be popularity and success, right? Cloudera seems to be #1 right now. Any questions on Hadoop? You can download it, it's free. You do not have to run it across any number of nodes. You can run it on one. It'll grind through your data one piece at a time. It's not hugely complicated. And these guys, all three of these companies they believe that they're intending to go public. And when they do, we'll see what happens. So this is kind of a Hadoopable problem, right? This is my Facebook map of where all my pictures are from, right? So it's just to illustrate the point, right? That you could take data from lots of different data sets and create something that might be meaningful. Well, it's only meaningful to me. And it's meaningful to people who actually care where I am or where I've been. But also, I used it because it really illustrates some of the key issues that are showing up with big data, right? And there's a guy running around from IBM, and he calls it the 4 V's: volume, velocity, variety, veracity, right? If you step back, right, my photographs in Facebook are exactly what you call huge volume. I mean, there might be 1,000 in there, and I've been a member for several years, and it's really easy with an iPhone or a BlackBerry to take lots of pictures and upload them. So I'm probably not their biggest user. But think about how many users Facebook has. and think about the fact that they're not organizing their data in any kind of meaningful way, right? They just keep more storage, more storage, more storage, and it's all linked together. And as I think is kind of interesting, sometimes sitting next to my wife and we're both looking at Facebook, our Facebook feeds. We have very similar sets of friends, and then you look at the feeds and you go, wow, you see that and I see this. These are not even close. So there is a lack of transactional integrity in the way Facebook works because of the way that they organize their data. So, I had a conversation with one of our investor relation guys. There was somebody who said, they're looking at investing in CA, and they're very concerned about our business model because the Facebooks and the Googles and the Amazons and the Yahoos of the world are just going to eat our business alive because, they're building these massively parallel environments, and they're just going to take all the credit card processing away from the big banks and Visa and FDC and those guys. I said, what are you talking about? Where did he get his information from? He goes, well, this is a big investor. He's got, an army of people. And I said, did he call anybody and ask who's doing the credit card processing for Amazon? And he said, well, it's the guy's name is Jonathan. He says, I don't know. He says, do you know who's doing the credit card processing for Amazon? I said, no. I said, but I could ask around. Right? So he started hunting up on the internet who was doing Amazon's credit card processing. And I started calling people at large banks, and I was told by several of the people in large banks that if I knew, I couldn't tell you, right? And so I did a little bit more digging, and I called up a credit card processing, clearinghouse bureau kind of person, and she said, it's JP Chase. And then I got a call back later, I shouldn't have told you that. And I said, it's okay, because I went out to Amazon's website, and do you know who underwrites Amazon's gift cards? JP Chase. So it gives you a little bit of insight, right? Why would they go with somebody else, right? If the infrastructure should be the same. So, when I talked to JP Chase guys, and I said, remember when you told me you couldn't tell me? Well, I know anyway. But it turns out that Amazon in the UK is using somebody else. But the point being that Amazon doesn't process any credit cards, right? Zero, none, and they are unlikely to do so in the future. I said to Amazon, right? JP Chase is the credit card cloud, right? That's the end of it. It's not going away, right? And I said, if you can convince the guy that that's true, we'll get an influx of money. If you can't, you're going to have to go find the next investor. But that's sort of the thing here, right? But so what it comes down to though is that on the big data side of things, right? It's all around what it starts to become a huge problem around dealing with the speeds and feeds, right? The kinds of the different forms of the data that you wish to deal with, right? Just think about people who are posting pictures, right? There's raw, JPEGs, pings, TIFFs, right? That's a whole lot of different forms to deal with. And if you wanted to process them all, right, I would argue that if all you do is process JPEGs, you're probably not going to get a reasonable analysis of things in pictures, right? And then there's the veracity problem, right? That you can go on this page, right, take a picture of Fred's Chinese restaurant and say it's in the middle of Beijing, right? They're not going to check you, and they're going to put a little circle, up here in China. They say one picture, right? And it'll also say that in your places, it'll also say that you've been to Beijing, China, because you posted the picture from there, right? So what good is it, right? So you have to have a whole lot of thought around what are you going to do to prove that the data that you're looking at is actually meaningful. There's been a lot of work in several states. I think Utah was one of them, where they're using their voter rolls, and they're going back and they're checking it with people who the property ownership rolls, right? So you got people who are voting. You have people who own property, there's probably an intersect there, right? And they're actually discovering that there are people voting multiple times, right, on variations on their name, right? And they're all using the same address, right? So that so part of the problem of the size of this data or dealing with data of this size is actually figuring out whether or not the data that you have is any good, right? Or if there's so many holes in it that it's not useful anymore. So these are some of the things. And so when I'm talking about this stuff, these are some of the things that we should be thinking about in terms of how this impacts our business. Because we're being asked by our customers to think about these technologies in the context of what we do, right? I think our, at least out of this site, right, probably the most important analytics product we have is iDash, right? Everybody heard of iDash? Hopefully, right now. And from a big data perspective, the data is not that big. And from an analytics perspective, the analytics is not really all that comprehensive, but it's meaningful. It gets the job done, right? It kind of goes back and says, hey, this job ran in 4 minutes today, 3 minutes yesterday, 7 minutes the day before, so it can do some sort of prediction about how it's going to run tomorrow. But if you step back and you say, okay, that's great, maybe I can do a little bit more, right? Most of the jobs that our customers run on the ZOS side of things are multiple steps. Do I need to go down the next level and start managing the steps, right? Do I need to go down to the next level and start to think about IOs that each one of those steps does, or CPU seconds that are consumed by those steps, to be able to help a customer predict where a problem might be? Because today it was 50,000 IOs, and yesterday it was 70,000 IOs, and the day before it was 30,000 IOs, right? Maybe there's information that we can get out of this stuff, right? The issues around some of the issues around big data are just trying to figure out what you can do with it and what's meaningful and what's not, right? Fun, right? Just like anybody looked at their LinkedIn, friend nexus, right? And all the different colors and stuff like that. Same kind of idea, right? They're just going through their database and drawing a different picture. So this is out on the internet. It's a real eye chart, but it really starts to talk about thinking, where the thinking is in some of the industries about this stuff. I should probably stand on the other side of the room a little bit, since I'm completely ignored Bob Florian. Right, but the issues are on the variety, right? Being able to pull together things that might not have the same format and being able to use them, right? There's a lot of pre-work that has to be done. And by the way, that pre-work is going to take CPU, it's going to take time, and it's going to take a lot of cleansing to make it work, right? And I think there's a couple of really nifty points here, right? 2.5 quintillion bytes are created every day. That's now. And prior to 2000, and this is a number from the Google guys, there was only 2.5 quintillion bytes created since the dawn of time. So now we're creating that every day. And every day, we're only creating more data sources, right? More monitors, more sensors. Every year, cars have more and more in them. Every year, medical devices have more and more in them. Every year, we got Google Glass, right? We got all this sort of stuff. Your phone is more and more aware of what's going on. So it's only going to get bigger. It's only going to get worse. And at some point, right, there's going to be more data stored than there are grains of sand on beaches, right? It's kind of a scary thought. So now, again, right, choosing the data to use to make sense of this stuff becomes important, right? The tweets as a set of data around sentiment, how you're doing or how you're not doing, is becoming more and more important. Being able to deal with the reasonability of this, right? It's no different than marketing and dealing with your customers today, right? There are just some people you're never gonna satisfy, right? They're just gonna tweet that you suck every day, right? They are. I mean, it's no different than than the guy who just got, he got hosed by some company, got hosed by Time Warner, right? And he's just going to tell everybody, never use Time Warner, never use Time Warner. I'm not saying that at all. I'm just saying that that's an example. I mean, I knew somebody like that from New York, and the guy was every day, man, I hate Time Warner. Well, who used satellite or something? I don't want to hear about it anymore. Well, my house doesn't face south was his answer. So but that's the kind of stuff, right? So now you have to deal with, how do I filter those guys out and get to the meaningful stuff? And these are the things that we can start to think about, right? We have products, any of the products from this site, most of the products from CA generate gouts of data. How many of those products actually save it? Almost none, right? So it's stuff to think about, right? So kind of on the other side of things. Hadoop is for big chunks of static data. Then there's a whole set of other technologies around consuming data as it occurs, right? The Twitter feeds, the ability to get stuff out of the system like ZOware, right? That just sits there and consumes the ZOS system log continuously and finds interesting patterns or looks for anomalies, right? This is huge. This is one of those things that just creates data. I can't talk in specific about it, but there's a bunch of people going to San Diego next week to talk to an acquisition target around work that's being done here to be able to help predict when ZOS is going to fail, particular subsystems are going to fail, whether your capacity needs aren't going to be met, that kind of consumes reams of data out of things like SysView and NetMaster. So this stuff is becoming highly important to our customers, right? I know everybody I talk to about ZOware from a customer perspective says it sucks, it doesn't work, it's terrible, but they have to keep working on it because it's not done yet, right? My assertion is that it'll never be done because there's always going to be more data, but the bottom line is it will get better and better and better because in and of itself, it's going to be able to consume enough data to understand where its predictions are falling short. And there'll be suggestions on how to fix those algorithms. It's not going to end. It doesn't end. Right? There's only ever going to be more data. So why do we care? Right? And I put the first one up there because it's a feel-good statement, but it's also not such a good feel-good statement. Right? You have to be real careful about this. Right? The mainframe securely holds about 70% of the world's operational data, and that's an IBM pronouncement. It's probably close to true, but you know what? Who cares anymore? Right? The amount of data coming out of Twitter every day is bigger than the 70% of the world's operational data every day. Right? This is what we have access to in our products. We have to start thinking about how we get access to other things. Right? It doesn't mean anything, I don't know, but how do we bring Twitter together with CA7? I have no idea, I just made it up, but you need to think about that sort of stuff, right? What other forms of data can we use in our products to make our products better? Or are there other kinds of sensory mechanisms we can put into our products? Are there feeds? I don't think that my Facebook, where I've been and taking pictures of feed is probably useful, but I'm sure that there's other stuff that's within the data center that matters, right? Is there something we can do with the service desk product? Because that is a stream. It's a stream of complaints. Right? Filter out the complaints that might have to do with Datacom or might have to do with NetMaster and deal with that stuff. This is where this stuff is going to need to go. It's important. Right? One of the other reasons why we care is, for the most part, the data that was part of all of that was used as the actionable data for business intelligence was mainframe data. I assert, no facts, but I assert that most of the stuff running in Oracle BI came from DB2 Datacom and IDMS. It is not the system of record, it's the system of ad hoc query. But because the cost of doing that ad hoc query on Datacom, IDMS, when DB2 was so high, customers just decided that the cost of moving it off and updating that every day was good enough for them, and that's what they're doing. Now, of course, if your data is stale as of 24 hours ago, not too useful anymore, right? Your customers are shifting, minute by minute. The stock market's moving millisecond by millisecond these days, even with SEC rules. You have to be able to deal with that in real time. And right, the guys who build this stuff are under attack. I went to GSE last year in the UK, and I didn't get him drunk, he was already drunk when I got up to the bar. But, one of the guys who was there, he's one of the storage administrators / database administrators at one of the banks, was chuckling about how he got the Teradata guy not to give him a 30% discount, but to drop the price to 30% of what they were taking before, simply by going, oh, we're thinking about Hadoop. Right, they go, whoa, you're thinking about Hadoop. Now, Teradata is it's not just one thing, it's many things, but some of what Teradata does to prepare the data for the back-end processing that Teradata does looks a whole lot like MapReduce. And those Cloudera guys, their biggest sales thing to do is to run in with a cluster of machines and say, I'll take down your Teradata cost. That's like the first thing that they do. right? You got Teradata, I have an answer to take down your cost, right? So they're basically stealing a piece of Teradata's wallet, right, and handing it back to the customer and taking it for themselves.